بسم الله الرحمن الرحيم. رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. النهارده ان شاء الله شباب we are going to talk about the chemical equilibrium learning outcome 12. chemical
دخلت يا ندى، خلاص دخلت.
chemical equilibrium. Okay, you can close your microphones. We will start by an experiment. This experiment for the equilibrium that taking place in the case of the water vapor. We'll bring the conical flask or bring the round bottom flask. Bismillah. Start the heating firstly for this round bottom flask. You close it and put an amount of the water vapor. Start the heating process. At the start of the heating process, what's happened? At start of heating, the rate of vapor formation is high. After the period, we will find the boiling process taking place. We remove after boiling. Remove it. Remove round bottom flask. And put it at room temperature. In this time, after the evaporation rate will become high, after we remove it, and we put it in the laboratory or at room temperature, we'll find the rate of condensation, it will be increased. Rate of condensation, it will be increases. Condensation rate increases till we reach the case of equilibrium, at which rate of condensation or rate of evaporation equal rate of condensation. In this part, we must return back to the very important definitions. What's meant by the vapor pressure? Saturated vapor pressure and the chemical equilibrium or system at equilibrium.
سوري بس ممكن تسأل. مستر
Yes.
سوري، بس هي بالنسبة لنقطة rate of evaporation equal rate of condensation، هل ده قصده إن نسبة ال evaporated water equal لل condensated؟
Condensated, yes. Okay. Return back to the concept like the vapor pressure. What's meant by the vapor pressure? It is the pressure exerted by vapor at certain temperature over the surface of liquid. So we'll find in the first case the vapor that will take the space inside the container. It will affect by the pressure over the surface of the liquid till it reaches the saturated vapor pressure. What's meant by the saturated vapor pressure? The maximum pressure of vapor at certain temperature. It represents the maximum vapor pressure that will close the space before the explosion taking place for this closed container. In the case of the system at equilibrium, what's meant by the system at equilibrium? System appear stationary, but in reality it is dynamic. From the first moment when you look through this conical flask, it appears constant, but inside it the movement taking place for the molecules. So according to this, what's the type of the chemical reaction? Reactions types. The reactions type according to the rate of the chemical reactions. We will find the instant reactions, we'll find slow reaction, and we'll find the very slow reaction.
هو مش دي كده بنتكلم عن reaction speed؟
The reaction type according to the rate of the chemical reaction or speed. Instant reactions mean reaction take the moment, like when we're making the reactions between the sodium chloride and aqueous solution and the silver nitrate also in aqueous solutions, it gives to us NeNO3 and the solid PBT from AgCl. The speed of this reaction is very high since it's taking place between the ions, positive and negative ions. Not take the time, and then it's called the instant reaction or instantaneous reaction. Instantaneous reaction or instant reactions. Maybe you will find the slow reactions like the reaction of caustic soda, sodium hydroxide, and oil to forming soap. This reaction is called one from the slowest reactions or slow reactions. Very slow reactions taking the weeks or months like the rusting process take place after the long period of the time. From this, we'll maybe determine the speed of the chemical reactions. What's meant by the rate or the speed of the chemical reaction? Rate of chemical reaction. The rate of the chemical reactions means the change in the concentration of reactant per unit time. And according to this, we have the two types of the chemical reactions according to the rate. Reaction according to rate. Firstly, you will find that the complete reactions and the complete reaction only reactions moves in direction of product formation only. Like the reaction of the sodium chloride with the silver nitrate. This reaction 1. The example of the reaction 1. And we will find the reversible reaction. In the reversible reactions, we will find both of reactant and product are founded in reaction medium. Let's talk about an examples. An example for sodium nitrate. The aqueous solution react with the sodium chloride, silver nitrate. So we'll find the sodium chloride, the aqueous solution, react with the silver nitrate. As in the aqueous solutions give to us NaNO3 plus AgCl, solid PBT is formed. Like the reaction of the calcium, decomposition of the calcium carbonate by the effect of the heat gives to us calcium oxide and the carbon dioxide gas. We can't return back the calcium oxide into calcium carbonate again, since it is a complete reaction. Like what's happened in the case of the reversible reactions? Let's talk about the examples of the reaction of the acetic acid, CH3COH, ethanoic acid. Common name is known as acetic acid. React with the ethanol or ethyl alcohol. Ethanol, ethyl alcohol as a common name. In this time, we will find these reactions move in the two directions, forward directions and backward, forward and backward. In this case, we will find that the reaction take place by which the alcohol, it will share by H only, and the acid share by OH. When I ask you the questions from which we can bring or forming the water, you said that acid it will share by H and alcohol share by OH. It's not correctly. In the esterification reactions, we will find the acid share by OH, while the alcohol share by H to forming the water. So the product of this reactions it will be CH3, COO, C2H5. This compound is methyl acetate ester called ethyl acetate ester and the water. For these reactions, we can prevent the reversible reactions by absorbing the water from the reactions by adding conc sulfuric acid. But now we will need to represent graphically this type of the reactions, reversible and complete. Graphically, if we put it in a graph between the concentration and the time, at the start of the reactions we will find the concentration of the reactant at the 100%, and at the end it will reach the zero. This is reactant. But for the product, start from the zero till it reaches the 100. For this is the product. In the case of the reaction at equilibrium or reversible reactions between the concentration and the time, you will find that the reactant decreases till it reaches the equilibrium, and we can determine the equilibrium from the graph when it's become parallel to the x-axis. This is reactant, and the product it will increase till it become the constant, and the both of the reactant and product are in the case of equilibrium is product. In reversible reactions that it be controlled by the thing it's called the chemical equilibrium. What's meant by the chemical equilibrium? Chemical equilibrium. What's meant by the chemical equilibrium? Chemical equilibrium takes place in reversible reaction. Reversible, not complete. Reversible reactions. Whereas both of the reactant and the product are in the medium of the reaction, and the rate of the forward product production equal the rate of backward reactant. So the equilibrium that controls the reversible reactions, the chemical equilibrium. Now we are going to talk about the factors affecting the rate of the chemical reaction. We'll find the factors affecting the rate of the chemical reaction. Number one, nature of reactant. Concentration, pressure, temperature. light, and the last one is catalyst. Let's turn back to discuss each factors affecting the speed of the reactant or the speed of the chemical reactions, starting by the nature of reactant. Nature of the reactants can be discussed through determine the type of the bond and the surface area. Bond type, surface area. Start firstly by the bond type. When having a two type of the bonds, when have an ionic bond and the covalent bond. In case of the ionic bond, the rate of the reaction is high as it takes place between ions. While in the case of covalent compound or covalent molecule, reaction rate is low or slow as it takes place between molecules. So, between the molecules, between ions versus molecules, making the reactions become fast or become slow. For the surface area, we'll perform an experiment to determine the speed of the chemical reactions. Add 10 milli of diluted HCl to post tube. We'll bring the tube that's contained in a 5 gram of zinc piece, 5 gram zinc piece, and by the dropper we'll add the 10 milli of diluted sulfuric acid, diluted HCl, to the piece of zinc and to the powdered zinc. Five gram of zinc powder. Else we added the dropper by the dropper. What's your observations? You will find that hydrogen gas evolves in both but the reaction end fastly in case of powdered zinc. As the surface areas increases, the rate of the reaction increases. Okay, so explaining the effect of the surface area and the rate of the chemical reactions, surface area and the rate of the chemical reaction. Let's assume when having two molecules. Let's assume that we have two molecules of reactants, three molecules of reactants, four molecules of reactants. We are going to talk about the collisions that take place between the molecule of the reactant. If we have the two molecules, maybe A and B, so the collisions maybe take place between A and B or B and A. But in the case of the three molecules, if we bring two molecules from A and one molecule from B, so we'll find the rate of collisions between the molecule of the reactant, it will be increased, since we'll find that the collision taking place between A and B, A and A in the medium of the reaction, B and A. But in the case of the four molecules, like the two molecules from A and the two molecules from B, you will find the rate of collisions increases also between A and A and B, B and B, A and B, or BB. This molecule may be collide with this molecule, and else this molecule will be collide with this molecules. So, as the number of molecules increase, as number of molecules increases, else we can set surface area increase. The rate of collisions increase. Between molecule increases and speed of the chemical reactions increase, and the rate or the speed of chemical reaction increase. Let's talk about the second factor that
مستر
affect.
ممكن سؤال معلش؟
Yes.
طب احنا ليه كنا بنقول ان المولكيولاريتي ما بتأثرش في الريت اوف رياكشن؟
Molecularity, it is the number of molecules that enter according to the limiting reactions. But we said in this case, the molecules react. Okay? When the molecule reacts, it means the concentrations is increased the rate of the chemical reaction. And we said that this reactions the case of reversible reactions. احنا بنتكلم في حالة الريفرسبل reactions أو عموما الرياكشن الكيميكال reactions العادية. تمام؟ النمبر اوف molecules مش بتأثر في الريت اوف ذا chemical reactions، لكن أنا بقول إن ال collisions between the molecule is increase in the rate of the chemical reactions. نشرحها بشكل بسيط. ماشي؟ 50 بنت قاعدين في كلاس واحد، بس 50 بنت دول هاديين، مفيش مشاكل، اهلا وسهلا. هل معدل حدوث المشاكل هيبقى كبير؟ لا طبعا.
تمام
10 بنات 10 بنات بس، لكن دول 10 بنات مشعوذات كده مش عاديين. فالريت اوف collisions between these molecules will increase. هي القصه كلها انا بنتكلم على الريت اوف collisions مش النمبر اوف molecules، فاهماني؟ احنا
تمام
بنقول ان
فهمت.
واحد من ضمن الاسباب اللي تسبب ان النمبر اوف molecules increase is increasing the collisions increase the rate of the chemical reactions. طيب let's talk about the concentration. Before the concentration we're taking this image. copy. بسم الله. The concentration. One from the factors that affect the speed of the chemical reactions is concentrations. Let's perform an experiment. This is an experiment for
مستر يعني الموليكولاريتي اللي هي في حالة لما يبقوا مفيش رياكشن.
the chemical, talking about the chemical kinetics, the molecularity related to the chemical kinetics, the rate for the reaction when it's colloid with each other. Sometimes we'll find the molecularity is not affect the rate of the chemical reactions. Sometimes we will find the molecule does not react. Molecule مهما كان عددهم ما بتتفاعلش خلاص، يبقى زي molecularity هنا not affecting the concentration, not affecting the rate of the chemical reaction. But we're talking if the collisions, we talk only about the collisions. As the surface areas increase, collisions between the molecules increase, the rate of the chemical reactions increase. لازم تاخدوا بالكم يا شباب، انا بقول molecule هتتفاعل مع بعضها. ماشي؟ لما عدد الموليكول بتتفاعل مع بعضها يزيد، يبدا بمنتهى البساطه الريت اوف ذا كيميكال رياكشنز انكريز. حضرتك معدل السعاده واكل الشوكولاته مثلا، لو انت كلت قطعه واحده من الشوكولاته خلاص يبقى معدل السعاده مش زي ما تاكلي 15 قطعه، بس ساعتها 15 قطعه تروح المستشفى. تمام؟ القصه كلها بقى تعالوا نتكلم let's talk about the concentrations and reactions. These reactions between iron trichloride. Iron trichloride solutions, the aqueous solutions that has the pale yellow color, iron trichloride. React with the ammonium cyanide, NH4 SCCN. Colorless compound, the aqueous solutions from the ammonium cyanide or cycyanide. These reactions take place in the two directions, reversible reactions forward and backward, positive, negative, positive, negative. Give to us Fe, SCCN, all three, iron cycyanate, this is have a red brick color, red brick color. And the colorless ammonium chloride, the also in the aqueous solutions, this is the solid substance, and the red colorless ammonium chloride and aqueous solutions. Return back to the balance of these equations. The iron is a trivalent, ammonium is monovalent, iron trivalent, ammonium is monovalent. The highest coefficient we reached it is 3, so must all the equation multiply in 3. This is 3 neglected, this is 1, multiply 3. This is 3 neglected, this is 1, multiply 3. Okay. From this image, you will find when it is at room temperature, cold water. At room temperature or at high temperature, strength of red brick color increase. The forward directions, but at low temperature, we'll find strength of red color decreases, form pale yellow color of iron trichloride. So from these reactions we'll find the rate, maybe this is called the rate 1 and the rate 2. Rate 1 are directly proportional to the concentration of the reactant FeCl3 and the ammonium cyanate NH4SCCN, but raised to the power equal the number of molecules from the reactions. We raised the concentration to the number equal the number of molecules. And the backward R2 directly proportional to the concentration of the product FeSCCN raised to the power 1 and NH4Cl raised to the power 3. By removing the proportional sign and replace it by the equilibrium constant K, so R1 equal K1 FeCl3 NH4 SCCN R3, R2 equal K2 Fe SCCN NH4 Cl power 3.
مستر سؤال معلش حضرتك عارف من الاوردر بتاع دي 3 ودي 1
not the order, it is the concentration. Will making the relationship between the rate of the chemical reactions and the concentration of the reactant raised to the power equal the number of molecules from the chemical reactions. يعني 3 دي جايه هي البالانس بتاع ال NH4SCN.
طب اللي ما استعملناش اللي هو القانون بتاع الريت ايكوال كي واللي هو A concentration في A times B وريزد الاوردر.
Power order. Now we are going to talk the rule, it's called the law of mass actions. Law of mass actions, Goldenberg and Beck said that we'll find the relationship between the rate of the chemical reactions and the concentration of the reactant raised to the power equal the number of molecules. ثواني وهتعرف الامر هيبقى ماشي ازاي.
بس الاتنين بيدونا نفس الانسر ولا ايه؟
لا خلي بالكم انا عاوزكم تخرجوا بره، احنا النهارده بنتكلم على reversible reactions. في حالة لما يكون at equilibrium أو reaction at equilibrium يعني. At equilibrium rate of the forward equal the rate of the backward. So R1 equal R2 represented by K1 multiply the concentration of FeCl3 multiply NH4 SCCN equal K2 Fe SCN multiplying NH4 Cl power 3. If we said that the K1 divided the K2.
سؤال معلش بجد، طب هي الكي ليه مختلفة في الحالتين؟ ليه مش هي؟
Because we find the rate for the forward and the rate for the backward, and we will collect them in the one equations. هنجمعها في one equation ما تقلقش. The K2 أو the K1 divided the K2 equal the Kc, equilibrium constant. Equal the concentrations of the product divided the concentration of the reactant. In this case, we'll find the law of mass actions. Law of mass action in a relationship done by Goldenberg and Weg. Goldenberg and Weg find the relationship between the rate of the chemical reaction and the concentration of the reactant. So we must take care that the law of mass actions are taking place between the rate of the chemical reaction and the concentration of the reactant. The law said that at the constant temperature, the rate of the chemical reaction is directly proportional to the partial concentrations of reactant H raised to the power equal the number of molecules
هي ايه partial concentration اصلا؟
Again, your questions.
ايه partial concentration؟
Partial concentrations, since the concentration change from the time to time during the chemical reactions for reversible reactions. So we said that the reactions move in the two directions. Maybe the concentration of one of the reactants increase or decrease according to the condition of reactions. So the Kc equal the product concentration times power of molecule number, the number, or we can say that the power equal the number of molecules. Power equal number of molecules. divided the product or divided the reactant equal the power equal number of molecules. Let's practice by any questions. Question 1. Calculate the equilibrium constant of the following reaction. H2 plus I2 give to us 2HI. If you know that the partial concentrations respectively hydrogen, iodine, and hydrogen iodide, zero point 0.221, 0.221, 1.56 molar. So from the rule we can set that the Kc equal the concentration of the product divided the concentration of the reactant or number of molecules. So it will be the product HI concentration raised to the power equal to number of molecules divided the concentration of the hydrogen raised to the power equal 1 and the concentration of iodine raised to the power equal 1. So 1.56 to the power 2 divided 0.221 multiply 0.221. Square bracket, this bracket represents the concentrations, okay? There is no unit for the Kc, this is the ratios between the two concentration. Another question.
50.3
Your question?
هتبقى الإجابة 50.3.
50.3.
ده انا جبتها 49.8.
50.3, no problem for the answer, you can calculate it. Return back to the another
مستر
question.
معلش سؤال، هو ليه انا ما بعتبرش يعني باخد ال H2 زي على بعضيها كده ال number of molecule بتاعتها 1؟ ليه مش ال H وال number of molecule بتاعتها 2؟
لا حضرتك number of molecules represent the number of moles in front of the element or compound. Return back to the number of moles, okay? طيب another questions calculate the concentration of NO2 in the following equilibrium reaction. Into O4 2 in O2. This process gases. And the Kc value equal 4.8 times 10 power negative 5. NO2 concentrations or N2O4 concentration. (0.16 molar). So from the equations we'll find the Kc equal the concentration of the product NO2 raised to the number equal the number of molecules divided the concentration of N2O4 raised to the number equal the number of molecules equal 1. Both equal the Kc. So the Kc value 4.8 times 10 negative 5 equal unknown value for NO2 divided 0.16. NO2 concentration equal the square root of 4.8 times 10 power negative 5 multiply 0.16. We can calculate it. It equal
2.77 times 10 power negative 3.
2.77 times 10 power negative 3. Another questions, but we'll find the idea in these questions. Question 3. Calculate. This is problems that it will be give us the general idea between the learning outcome for the chemical analysis and this learning outcome. Calculate the equilibrium constant. For the following reaction. N2 plus 2H2 or 3H2 give to us 2NH3 and the container volume was 0.5 liter and it contains 0.6 mole of N2 and 0.2 mole of H2, 0.6 mole of ammonia gas. To solve this, we must return to calculate the concentrations. Number of moles equal molarity times the volume by liter. So to calculate the concentrations or molarity, the concentration, molarity, when we have a molarity for nitrogen gas, molarity for the hydrogen gas, and also the molarity for the ammonia gas. The rule is a constant. The molarity equals the number of moles divided the volume by liter. So molarity equal number of moles divided the volume in the liter equal, in the case of nitrogen, equal 0.6 divided 0.5 give to us
1.2.
Okay, 1.22 for the hydrogen,
0.4.
0.2 divided 0.5 equals 0.4, and else for the ammonia equals 0.6 divided 0.5 equals 1.2. Return back to the concentrations. Kc equal the concentration of NH3 raised to the power equal 2 divided the concentration of the nitrogen multiply the concentration of the hydrogen raised to the number of molecule equal 3. NH3 concentration 1.2 power 2 divided 1.2 firstly for the nitrogen and 0.4 power 3 for the hydrogen, and we find the answer. Another questions, but we return back to the value, another values in the following.
هي الأنسر هتبقى 18.75
0.75
18.75
18.75. Okay, تمام. Return back to another question. ماشي okay, no problem. Return back to the another questions. In the following reaction, the following data are recorded at 400 degree Kelvin. Values by mole per liter for the concentrations. PCl5 forward and backward give to us PCl3 plus Cl2. Okay, the data Cl2, BCl3, BCl5, trial A, trial B, and the trial C. Zero point 55, 0.11, 0.4, 0.99, 0.15, 0.2, 0.02, 0.003, 0.072. Thus, these values indicate the law of mass action and or no with reason. Firstly, the law of mass action says that the Kc equal the concentrations of the BCl3 and chlorine gas as a product raised to the number of molecules equal 1 divided the BCl5. So, firstly, return back to the values for the first trial, second trial, and the third trial. Trial 1, Kc equal 0.2, 0.55 divided 0.22 or 0.02, and the trial 2, trial 3,
trial 1 5.5.
5.5. Trial 2, the Kc equal 0.15 multiply 0.11 divided 0.003
5.5 برضه.
5.5 and the trail 3 else equal 0.9999 0.4 divided 0.072
5.5.
it tells 5.5. So as we will find the Kc value are equal in all trail this indicate the law of mass action. So if the values of the concentrations are equal in all trail, this is represented that the Kc or the law of mass actions. Note, what from the note? If he asks you reaction at equilibrium or not, calculate the Kc. If the values are equal in trials, so reaction at equilibrium. Okay, another question. One mole, this is question number 3, I think. I thought that is a question number 3 or 4. This question 3, this is question 4, this is question 5. One mole of hydrogen mix with 1 mole of iodine and 0.2 mole remain. From H1, H2 plus I2 give to us 2HI. Calculate the equilibrium constant Kc if you know that the concentrations or the container volume equal to liter. We must return back to the ice method. H2 plus I2 gives to us 2HI. Initial concentration, changeable concentration reaction at equilibrium. At the start, we will find the number of moles is 1 for the reactant and 0 for the product. It is changed by the rate equal x, decreases by x. And this is increases by 2x. At equilibrium, 1 subtract x, 1 subtract x plus 2x. And if we know that the values of the x's was 0.2 decreases by 0.2.
هو معلش السي بترمز لإيه؟
X represent the change initial concentration, change in the concentration equilibrium. Okay, so x equal 0.2. Okay, 1 subtract 0.2, so the x one subtract x, 1 subtract x, so the x it will be equal 0.2. Since the remains, it represents the remaining substance or the reactant substance, the change in the concentration. So in this case, we'll find 1 subtract the reacting substances, 1 subtract 0.8, it remain only 0.2. And in this case, 1 subtract 0.8, the reactant substance, the remaining 0.2, the remaining moles. This is represented the final number of moles. And thus 2 multiply 0.8 equal 1.6. For the volume container, when I have a 2 is a constant, the volume not a change. Return back to the concentrations. Molarity or concentration. Concentration represents the number of moles divided the volume in the liter. So 0.2 divided by 2 equals 0.2. Okay, 0.2 divided by 2 equals 0.1. 1.6 divided by 2 equals 0.8. Now we can calculating the value of the Kc. Kc equal the concentrations of the product Hi raised to power 2 divided the concentration of the hydrogen and the iodine.
64.
So, okay, 0.8 power 2 divided 0.1, 0.1 equal so the value it will be equal what? What is the answer?
64.
64, okay? Now we return back to talk about the notes for calculating the Kc. Notes to calculate Kc. Number 1. In calculating Kc, the concentration of liquid water, liquid ammonia, solids, BBTs, not considered. as it constant. An example, in the following reaction, Zn as a solid substance plus 2HCl give to us ZnCl2 plus H2. In this case, to calculate the value of the Kc, this is the aqueous, gas, aqueous, we said that the Kc equal the concentration of the product divided the concentration of the hydrochloric acid raised to the power 2 and neglect the solid. Else, to calculating the equilibrium, Cu as a solid substance plus Ag2S give to us CuS as a solid and 2Ag as a solid else. So the Kc in this case equal 1 divided the concentration of the aqueous solution of silver sulfide, Ag2S only.
بس أنا مش فاهمة ليه بنشيل السوليد، يعني ايه هو
Silver sulfide in the aqueous solutions, so take care only from the aqueous solutions and neglect the solids.
اوكي. طب ما هي الليكويد ووتر ليه ما بتتاخدش في الليكويد امونيا؟
The liquid ammonia and the liquid water are the concentrations constant, not a change according to the change in the reactions. So as it's the constant, it occur from the constant concentrations in the calculating the Kc. So when I have the water, the liquid, and the station of the water is given to us H positive plus OH negative. To calculating the Kc, in this case it will be only the concentration of the product divided 1, neglected the effect of the liquid water. The Kc graphs. Kc graphs and cases. As we know that the Kc equal the concentration of the product divided the concentration of the reactant. Sometimes we will find the different graphs between the concentration and the time. Like this graph. This represented the reactant and represented the product, and the concentration of the product greater than the concentration of reactant. So the value of the Kc in this case is greater than 1. Another case, find the concentration and the time. We'll find the reactant, we'll find the product, but still the reactant concentrations greater than the product concentrations. So the Kc in this case less than 1. Concentration and time both the reactant and concentrations of the reactant and the product are equal. Reactant concentration equal the product concentrations. So the Kc in this case equal 1. If we return back to the Kc and the temperature, as the Kc value increase the temperature by increasing the temperature, this represents endothermic reaction. As the Kc value decrease by increasing the temperature, This represents the exothermic reaction. And this point, inshallah, we are going to discuss it in the next session, inshallah. See you soon, inshallah, tomorrow. But no anyone from you will leave before check the attendance. Bismillah ar-Rahman ar-Rahim. Okay. Okay, my dear student, I will upload this lecture, inshallah, on the YouTube today, inshallah, and you can return back to discuss in the effect of the KC and the temperature in the next session. See you soon, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.
وعليكم السلام.
وعليكم السلام.
السلام عليكم.